3 minutes ago is when it happened. 3 minutes ago, two of the most powerful telescopes ever built by human hands, the James Webb Space Telescope and the Vera Rubin Observatory, simultaneously confirmed they were both looking at the exact same object. Not through any coordinated plan, not through any prepared strategy. They both ended up staring at it independently, separated by millions of miles of space, both collecting data on something that shouldn't have been in our solar system at all. By the time you finish watching this video, you will understand exactly why that moment matters so much, why astronomers around the world started racing to their screens the moment they realized what had just happened, and why the object they were both looking at is absolutely nothing like what the internet is claiming it is. Because right now, an ancient traveler from the far reaches of our galaxy is passing through our solar system. It arrived unannounced, it will leave permanently, and for one brief window of cosmic time, we have some of the most advanced instruments in human history ready to study it before it's gone forever. Right now is the moment that matters. But this story actually starts 10 days earlier, before anyone on Earth even knew this object existed. It starts with a discovery, then a rediscovery, and finally, confirmation from the most powerful instruments humanity has ever built. It starts with coincidence meeting precision, with accident meeting ambition, with an ancient visitor from the galaxy meeting a species that finally has the tools to study it. On July 1st of 2025, a survey system called ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, spotted something moving through our solar system from a facility in Rio Gerardo, Chile. At first, it got a technical label, C2025N1, but within days, astronomers confirmed something remarkable. This object was not from our solar system at all. It had come from somewhere else entirely, out of interstellar space, and it was only the third such object ever confirmed in human history. It was given the name 32 Atlas, and almost immediately, observatories around the world turned their attention toward it. Here's where the story gets genuinely interesting, and where those two telescopes enter the picture together. A few weeks after the official discovery, scientists working with the brand new Vera Rubin Observatory in Chile went back through their archived data. Just routine housekeeping, standard archival work, checking old test images from a testing phase called science validation. That's when they found it, sitting quietly in the background of images taken on June 21st, 2025. 10 full days before ATLAS ever announced the discovery. 10 full days before most of the world even knew this object existed. Vera Rubin had already photographed it multiple times. Nobody at Rubin Observatory even knew it was there at the time. The telescope wasn't hunting for interstellar objects that night. It was doing something far more mundane, calibration work, testing its systems, pointed in a direction that happened purely by chance to include the exact patch of sky where this interstellar visitor was quietly passing through. That's the kind of astronomical luck that might happen once in a generation. A brand new telescope, on one of its very first test nights, accidentally photographs a previously unknown interstellar comet simply because it happened to be looking in the right direction at the right moment. Rubin continued to accidentally photograph the object all the way through July 20th, 2025, collecting nearly 100 exposures in total. Researchers eventually used 49 of those images in a full scientific study. This makes Vera Rubin Observatory's images among the earliest and highest resolution pictures of 32 Atlas that exist anywhere on Earth, captured entirely by accident before most of the world even knew the object was real. But what did those images actually show? What did scientists see when they looked at this ancient visitor? Rubin's data revealed that the object had a growing coma, meaning a cloud of gas and dust surrounding its core. That cloud expanded by more than 50% during the observation window as the object moved closer to the sun and started heating up. That alone is completely normal comet behavior. Comets have been doing exactly this for billions of years, releasing gas and dust as they approach their closest point to the sun. But there was one detail that genuinely surprised scientists. The object had a dust tail pointing toward the sun instead of away from it. Under normal circumstances, a comet's tail points away from the sun because sunlight physically pushes dust particles backward. A sunward-facing tail is rare, though not completely unheard of. Researchers have seen a similar effect in at least one other distant comet before. Scientists explain this using something called anisotropic dust emission, essentially meaning the dust wasn't being released evenly in all directions from the object's surface, which can create unusual tail shapes depending on the angle of observation and the specific way the ice sublimated off the nucleus. It is a strange detail. It is an interesting detail. But it is explainable science, not a mystery with no answer. Scientists have a framework for understanding exactly why this happens. Before we go further into the chemistry side of this story, it's worth understanding exactly what kind of telescope managed to catch this object completely by accident. The Vera Rubin Observatory sits on a mountain called Cerro Pachón in Chile, a location chosen specifically because of its dry air and dark skies, ideal conditions for observing faint objects in deep space. Its main mirror is 8.44 meters wide, roughly as wide as a tennis court is long. And attached to it is the LSST camera, the largest digital camera ever built, capable of capturing 3,300 megapixels in a single image. When this observatory photographed 32 Atlas, it had not even officially started its real mission yet. It was still in a testing period called science validation, essentially a dress rehearsal phase where engineers and scientists check every part of the system, the optics, the camera, the software pipelines, before the real 10-year survey begins. During this phase, the telescope is pointed at various patches of sky simply to test image quality, calibration accuracy, and system reliability, not to hunt for specific objects. That is exactly why nobody realized 30 Atlas was sitting inside these test images for weeks after they were actually taken. Researchers only found it later after the official discovery announcement when they went back through the archived commissioning data specifically to check whether the object might have shown up earlier by coincidence, and it had, hiding quietly in the background of ordinary calibration images 10 full days before the rest of the world even knew to look for it. Here's the part that shows just how good this discovery process actually was. Rubin captures images across 6 different filters covering different colors and wavelengths of light, often referred to using the letters U, G, R, I, Z, and Y. This multi-filter approach allows scientists to gather data across a range of wavelengths, building a more complete picture of the object's behavior. Scientists were able to measure the object's position across all of these different bands with a typical precisions of about 70 milliarcseconds. A measurement so precise it equals the width of a human hair seen from a distance of several kilometers. An extraordinarily tiny angle when you consider how far away and how faint the object actually was at that point. For comparison, Rubin's general precision on fixed unmoving background stars is even sharper, closer to just 3 milliarcseconds. So the slightly coarser precision on 30 Atlas simply reflects the challenge of tracking something that is actually moving relative to the background sky. This level of detail allowed the research team led by astronomer Colin Orion Chandler, along with more than 300 other collaborating scientists, to publish a full paper analyzing the astrometry, meaning precise position tracking, along with the brightness, shape, and activity levels of the comet based entirely on this accidental early data. Rubin had given scientists the earliest possible timeline of this object's approach to our solar system. Now let's talk about James Webb, because this is where the story really connects. On August 6, 2025, the James Webb Space Telescope turned its near-infrared spectrograph instrument, called NIR-SPEC, directly at 3 Atlas. This was Webb's first real look at the object, and it followed observations already made by the Hubble Space Telescope and NASA's SPHEREX mission. Webb's job here was different from Rubin's. Rubin captured images, essentially photographs, showing shape, brightness, and movement. Webb went further using spectroscopy to actually break down the light coming from the comet and figure out its chemical composition, almost like a fingerprint of its birth environment. And Webb found something unusual almost immediately. Inside the comet's coma, scientists detected carbon dioxide, water, water ice, carbon monoxide, and a smelly compound called carbonyl sulfide. All fairly typical comet ingredients on their own, but the ratio of carbon dioxide to water was the highest ever recorded in any comet observed by scientists, whether solar system or interstellar. That ratio matters because it tells astronomers something crucial about the environment this object originally formed in. Environments with different temperatures and different amounts of sunlight produce different chemical ratios inside a forming comet. This object's ratios suggested formation conditions unlike anything we typically see in our own solar system's comets. Then, in December 2025, Webb looked again. As 32 Atlas made its closest pass by the Sun on October 29, 2025, a moment scientists call perihelion, the comet's ancient ice began rapidly turning to gas, creating a brighter, more active coma that was perfect for detailed observation. Webb captured this moment on December 22, 2025, right after the object made its closest approach to our own Earth on December 19th, passing at a safe distance of about 168 million miles away, roughly 270 million kilometers, posing zero threat to our planet at any point during this entire encounter. In this second, deeper look, Webb measured something even more revealing. Specific ratios of carbon and deuterium, sometimes called heavy hydrogen, locked inside the comet's ice. These exact ratios do not match anything found in comets that formed inside our own solar system. Working backward from that chemical signature, researchers were able to estimate where and when this object was actually born. And the answer was absolutely staggering. Based on Webb's data, scientists calculated that 30 Atlas formed somewhere between 10 and 12 billion years ago in the early Milky Way galaxy. For comparison, our own solar system, including Earth, the Sun, and every planet we know, is only about 4.6 billion years old. This means the ice and dust that make up this comet were already floating through space, frozen and unchanged for billions of years before our own sun even finished forming, before Earth existed, before any life ever emerged on this planet. Some researchers have pointed out that this makes 33 Atlas nearly as old as the universe itself, which is estimated to be roughly 13.8 billion years old. This research was formally published in the scientific journal Nature on June 22, 2026, after passing through peer review, meaning independent scientists checked the data and the conclusions before it was allowed to be published. The evidence was solid, the analysis was rigorous, the answer was clear. Now, here's the honest answer to the big question everyone online keeps asking. Is this the terrifying alien object some corners of the internet keep claiming it is? Is it some kind of probe or engineered spacecraft or artificial construct designed by some distant civilization? Is it a weapon? Is it a messenger? Is it evidence of something out there that we should be afraid of? The answer to all of these is no, it is not. It is something far more natural, far more comprehensible, and honestly far more beautiful than any of those speculations. Scientists have been extremely clear and consistent about this, and it is worth walking through exactly why they are so confident rather than just taking their word for it. First, the object behaves exactly like a comet is expected to behave, developing a coma as it approaches the sun, releasing gas and dust in a pattern that matches physical models built from decades of studying comets inside our own solar system. These are not new patterns. These are not unusual behaviors. These are textbook comet responses to solar heating. Second, the chemical composition detected by Webb. Carbon dioxide, water, water ice, carbon monoxide, and carbonyl sulfide are all completely ordinary comet ingredients. The same basic building blocks scientists have already cataloged and studied for decades. Found in comets that formed right here in our own solar system, just present in a different ratio, which tells us about temperature and formation conditions rather than suggesting anything artificial or engineered. Third, the object's trajectory follows the predictable laws of gravity and orbital mechanics, with no unexplained deviations, no sudden changes in speed or direction that couldn't be explained by natural outgassing. The same kind of small course corrections comets have shown for as long as we've been tracking them. Every single measurement, from Rubin's early images to Webb's detailed chemical analysis, points to one conclusion. This is a completely natural interstellar comet made of ordinary ice, gas, and dust. Just like the comets we already study inside our own solar system, only far, far older and coming from somewhere outside of it. Astronomers have said directly that the evidence proves 33 Atlas is not an alien probe. And they have emphasized that trying to frame it that way actually undersells how genuinely amazing the real science actually is. Because think about what this object actually represents. It is a physical sample, a real chunk of frozen material from another region of our galaxy entirely, from a very distant time before our own sun even existed and before Earth had ever formed. That just happened to drift close enough for our telescopes to study it in detail. Scientists have compared this kind of opportunity to finding a message in a bottle that has been floating across an ocean for billions of years, except in this case, the ocean is the entire galaxy and the bottle is made of ancient ice instead of glass. That is not science fiction. That is one of the rarest natural events astronomers could ever hope to witness in their entire careers. And it happened to occur at the exact moment humanity has some of the most advanced telescopes in history ready and pointed at the sky. It's also worth understanding why this particular chemical signature was so useful for figuring out the object's age in the first place. Deuterium, sometimes called heavy hydrogen, is a slightly heavier version of a normal hydrogen atom. It has one proton and one neutron, compared to regular hydrogen's single proton. And the ratio of regular hydrogen to deuterium found inside ice can act almost like a chemical clock, a record of conditions when the ice first formed. This ratio changes very slowly and predictably based on the temperature and radiation conditions present when that ice first formed billions of years ago and whatever cold distant cloud of gas and dust eventually became this comet. By carefully measuring that ratio using Webb's near-infrared spectrograph, researchers could work backward and estimate not just how old the ice is, but roughly what kind of environment it originally formed in. Something scientists call galactic chemical evolution. Because our own galaxy has been slowly changing its chemical makeup over billions of years, as generations of stars have lived, died, and seeded space with heavier elements. An object formed extremely early in the galaxy's history carries a slightly different chemical fingerprint than something formed more recently. That is exactly the kind of subtle signature Webb was built to detect, and exactly why an interstellar object like 3 Atlas is such a valuable target. It is essentially a frozen time capsule from an era of our galaxy that no telescope has ever been able to sample directly before. Now let's put some real numbers on the table because the scale of this object is genuinely impressive on its own. 30 Atlas is only the third interstellar object ever confirmed passing through our solar system, and comparing it to the first two really helps show why scientists are so excited about this particular visitor. The first was Oumuamua, discovered in October 2017 by a survey telescope in Hawaii. Oumuamua was unusual because of its strange elongated shape and because it showed a small unexplained acceleration as it left the solar system. Something that briefly fueled a lot of speculation online, though the vast majority of astronomers concluded this was most likely caused by gas venting off its surface, a completely natural process, simply one, that was harder to directly observe, given how faint and distant the object already was by the time telescopes caught up to it. The second interstellar object was Borisov, discovered in 2019 by an amateur astronomer in Crimea. Borisov behaved much more like a familiar, ordinary comet, complete with a visible tail and a coma, which made it easier for scientists to study and compare directly to comets that formed inside our own solar system. 30 Atlas is the third and, in some ways, the most extreme of the three. Its orbit is far more hyperbolic, meaning far more sharply curved and open-ended than either of the previous two objects. Scientists measure orbital shape using a number called eccentricity, where a value of exactly 1 marks the boundary between an orbit that eventually loops back and one that never returns. 30 Atlas has an eccentricity of about 6.14, an extremely high number that confirms this object was moving so fast on such a wide open trajectory that it was never gravitationally bound to our sun at any point in its journey. It traveled at roughly 137,000 miles per hour as it approached the inner solar system, an almost incomprehensible speed that leaves no doubt this object simply originated somewhere else entirely, passed through briefly, and is now leaving again permanently on a one-way trip that started somewhere else in the galaxy and will end somewhere else entirely long after it leaves our cosmic neighborhood behind for good. Based on its speed and trajectory, researchers calculated something called a kinematic age, essentially estimating roughly how long the object has likely been drifting through interstellar space, and their estimate landed somewhere between 3 and 11 billion years, a range that lines up closely with the separate chemical age estimate that came later from Webb's data. The two independent methods of dating this object agreed remarkably well. Researchers have also noted that, statistically speaking, it is extremely unlikely this object has passed anywhere near another star as closely as it just passed our own sun, meaning our solar system may be the closest stellar encounter this ancient traveler has had in billions of years of drifting alone through the emptiness of the galaxy. Hubble Space Telescope observations helped scientists estimate the size of the object's solid core or nucleus, placing it somewhere between about 440 meters and 5.6 kilometers wide. A fairly wide range, because measuring the exact size of a small, distant, actively outgassing object is genuinely difficult even for our best instruments, since the bright surrounding coma of gas and dust tends to hide the true edges of the solid nucleus underneath. On top of Hubble, Rubin, and Webb, other missions joined the effort too, turning this into one of the most heavily observed objects in the recent history of astronomy. NASA's SphereX mission observed infrared light coming from the object's coma, detecting dust, water, organic molecules, and carbon dioxide, adding another layer of confirmation to what Webb had already found using a completely separate instrument and a slightly different wavelength range. NASA's TESS mission, usually used for hunting planets around other stars by watching for tiny dips in starlight, was also redirected for a special observation run, specifically to study the comet's activity and rotation. An unusual but valuable use of a telescope not originally designed for comet science. Even a European spacecraft called JUICE, which is currently on its way to study Jupiter's moons, managed to capture an image of 30 Atlas in November 2025, as it happened to be in a useful position along its own separate journey through the solar system. In total, this makes 30 Atlas one of the most thoroughly observed interstellar objects in history, studied by an entire international lineup of telescopes and spacecraft, all pointing at the same tiny ancient traveler at different points during its brief visit through our solar system, each one contributing a different piece of the overall picture. So why does it matter that Rubin and Webb both ended up looking at the exact same object? Because together they represent two completely different but equally powerful ways of studying the universe. Rubin Observatory is built for speed and coverage, scanning huge sections of the sky constantly, which is exactly why it accidentally caught 30 Atlas in the first place, purely because it happened to be testing its systems in the right place at the right time. Webb, on the other hand, is built for depth, for extremely detailed, extremely precise observations of one target at a time, which is exactly how it managed to pull apart the comet's chemistry down to individual molecules and isotope ratios. One telescope found the object first, completely by accident. The other telescope figured out what it actually was, where it came from, and roughly how old it is. Neither discovery would mean nearly as much without the other. Rubin gave scientists the earliest possible timeline and detailed shape data. Webb gave scientists the deep chemical proof needed to trace this object's origin back billions of years into the history of our galaxy. When you put those two sets of data together, you get a complete picture. You understand not just what this object is, but where it came from, when it formed, and how it traveled through space for more than 1 billion years before encountering our planet. This story also says something bigger about where astronomy is heading right now in 2026. The Vera Rubin Observatory officially began its 10-year survey of the sky on June 30th, 2026, called the Legacy Survey of Space and Time. Its entire purpose is to scan the sky repeatedly every few nights for an entire decade, catching exactly these kinds of unexpected objects, asteroids, comets, and rare interstellar visitors, often before anyone else even knows to look for them. The fact that Rubin managed to accidentally photograph an interstellar comet before it was even officially discovered, while it was still in its testing phase, months before its real survey even began, is a genuine preview of what this observatory is going to be capable of once it is fully up and running night after night for the next decade. Scientists expect more interstellar objects to be found over the coming years as this survey continues. And when they are, there's a very real chance Rubin Observatory will be one of the first instruments on Earth to spot them, simply because, unlike almost every telescope before it, it genuinely never stops watching the sky. Meanwhile, James Webb continues doing exactly what it was built to do, taking whatever object gets discovered, wherever it comes from, and breaking its light down into detailed chemical evidence that tells us where it was born and how old it is. This is possible because Webb operates far out in space itself, orbiting roughly 1.5 million kilometers from Earth, away from the heat and light interference of our own planet, allowing its infrared instruments to detect incredibly faint signals that would otherwise be completely lost from telescopes sitting on the ground. Together, these two observatories, one constantly scanning wide areas of sky from a mountaintop in Chile, one capable of incredibly precise deep analysis from deep space, form a kind of early warning and deep investigation system for anything unusual that passes through our cosmic neighborhood. 36 Atlas just happened to be the first major example of these two systems working together, even though nobody actually planned it that way. And it almost certainly will not be the last. Right now, 30 Atlas has already passed its closest point to the Sun and to Earth, and it is now moving back out of our solar system, heading off into deep interstellar space again, quietly and permanently. Scientists continued gathering more data as long as the object remained observable, right up until it became extremely faint and much too far away to track effectively, coordinating observations across ground-based telescopes, space telescopes, and even a spacecraft on its way to Jupiter, all working together to squeeze every last bit of usable data out of this brief one-time visit. What we are left with is a genuinely remarkable scientific record. A comet born 10 to 12 billion years ago, drifting quietly through the galaxy for almost the entire history of the universe, before briefly and completely by chance crossing paths with a handful of human-made telescopes on a small, quiet blue planet, orbiting our sun in such a way that, for a few months, the most advanced instruments in human history were ready to observe it. Long enough for us to photograph it, analyze its chemistry, calculate roughly how old it actually is, and trace where it came from before it disappears again for good, likely never to be seen by human eyes or instruments again. Returning to the darkness of interstellar space, carrying with it knowledge about the galaxy's chemical history from an era before Earth existed. That is the real story here. Not an alien object, not a terrifying threat, but something arguably far more impressive. Direct physical evidence from a completely different corner of our galaxy, formed before our own solar system even existed, confirmed independently by multiple world-class telescopes, working completely independently of each other. And in Rubin's case, working completely by accident, simply because it happened to be pointed in the right direction on an ordinary test night, just like that message in a bottle drifting across the cosmic ocean for billions of years. This ancient traveler finally touched the shores of human observation, and for one brief moment we were ready to listen. It's a genuine reminder that some of the biggest discoveries in science don't come from searching harder. They come from having good enough instruments, running often enough, that when something rare finally drifts past, you're already there to catch it.